Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Hajar binti Abdul Aziz KRISH. My matric number CE190033, and we are from Group 2 in Section 3. We'll present our project for BEV40403 High Voltage Engineering. The introduction. The insulator is a critical component for preventing overhead and underground current from flowing from the steel tower to the ground. Mechanical and electrical stresses must also be tolerated by insulator. Insulator must function properly for a transmission or distribution line to function properly. A good insulator is needed that is strong mechanically, electrically, and has a high relative permittivity. Each insulator design must go through a series test to ensure desired insulator performance and avoid insulator failure. There are 3 types of tests are performed on insulator, which is flashover test, performance test, and routine test. Implementing the finite element analysis FEA through finite element method magnetic FEMM. By using FEA through FEMM, the method of computing potential difference and electrical field disturbance is carried out in order to provide information on the state of our insulation design. The risk of corona and the occurrence of flashover can be reduced in this project carried out with high voltage insulator testing design. For problem statement, overhead insulators' ability to insulate power lines while also supporting the weight of the line conductor is critical to the transmission system. An insulator proper operation is critical to a transport or distribution line's proper operation. To withstand mechanical loss and stresses, a good insulator must have mechanical strength. To withstand operating and flashover voltage, it should have a high dielectric strength. An insulator should be free of any pores or void that could cause damage. As a result, each insulator must undergo a series of tests to ensure that it meets the required specification. For the objective, the 4 objectives listed below are the goals of this project. Number 1, to design an overhead line insulator while adhering to the formal literature specific requirements. Number 2, using SketchUp software, create a 2D or 3D drawing of the proposed design. Number 3, analyze the model's performance in terms of voltage distribution, electric field distribution, and breakdown voltage of the proposed insulator design in wet, dry, clean, and contaminated condition using FEMM simulation software. Number 4, to perform a test setup on the proposed model using an appropriate standard operating procedure, which include equipment protection and operation method. For the scope, the project constraints in this element are follows. Number 1, FEMM software is used in the simulation. Number 2, the insulator is designed in 2 dimensions and 3 dimension in SketchUp software. Number 3, the potential difference and electric field strength distribution are used to assess the insulator's performance. Number 4, simulating and testing the insulator in 2 different environments, which is a wet and dry environment, as well as a clean and contaminated surface. And number 5, test procedure of 132 kV EHV transmission line fittings. For the outcome of the work, the design of an insulator for a 132 kV system voltage is proposed. A string glass insulator with a maximum length of 1540 mm and a quick patch clearance of 7700 mm was used in the FEMM simulation software. According to the design summary, the conductor size is and the fitting option used is cap and pins. Every design parameter and material used has an effect on insulator performance, including cost. As a result, appropriate research and study are required to determine the parameter used in the design of the insulator. A previous study found that glass outperformed ceramic due to its mechanical comprehensive strength, which is 1.5 times that of ceramics. The clean glass insulator voltage is evenly distributed and gradually decreases from high to low voltage. In other words, a large portion of the system voltage is shared by a number of first shed of insulator from the line for polluted insulator. And contamination tends to increase electric field strength. The comparison of voltage distribution and electric field in three different conditions was discussed in the final section of this paper. There are dry clean, wet clean, with and without insulator contamination. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is RIZUAN ZAID. Today, I would like to present the technical summary of children's concept design. So this project scope is limited to 132 kilovolt system voltage due to the interconnection of National Grid Malaysia and Thailand. The 132 kilovolt system voltage must be implemented with the best capability of insulator properties such as suitable type of insulator, types of material, and fitting option that can meet the project requirement with the maximum length of 1544 millimeter conductor size, which is 175 millimeter square AAC, and KRISH clearance 7700 millimeter. So there are a few physical characteristics for the insulator. The first one is glass. So because of the glass, glass is the most effective insulator. RDS has a mechanical comprehensive strength is 1.5 times that of ceramics. Glass has an advantage over ceramic. Glass has more advantage than porcelain because of the way the shares. Next, for the string glass can save money while reducing the accumulation of electrical charge around the insulator face. Then it boats the charge will cause current leaks, arc, and flashover, extending insulation breakdown. Next, for the third one, we have cap and pins. Cap and insulator as well as high level strain connection of substation busbar are used in this project. By connecting the required number of individual unit, almost any KRISH distance can be achieved. Next, for the maximum lag and the KRISH clearance, the leakage of KRISH clearance admittance of an insulator is proportional to its overall strength. The KRISH distance of the insulator will increase as the string length increase as SSD expressed as represent the number of contaminant deposit on the insulator surface as the insulator string length grow. So last, for the conductor, the AC properties are lightweight and are used when with the mechanical system and reduced size are required. The voltage rating of these overhead lines varies depending on the type of installation. Despite its higher corona limit, the CSR has advantage in high and extra high voltage transmission. That's all from me. Thank you.
Okay, hello everyone, especially to Dr. Rahisham. Okay, my name is SCOVIEN Lawrence. My metric number is CE190077. Okay, I'm going to present about the process flow FES simulation. So the insulator design in FEMM software begins with setting up the coordinates in the software according to the parameters of each disk. To design a 2D model of the insulator, the coordinate drawing must be calculated. The voltage and electric field strength are observed in various conditions using the insulator simulation. So this is the technique of modeling the insulator in the FEMM, which is first planning. Find three different permittivity conditions, then drawing, planning the coordinate of 13 disk insulator, then simulate the voltage and electric field strength. So finding diverse conditions to test the insulator is the first step in the insulator testing process. We request that the testing conditions be dry, moist, and have salt pollution near the beach in the project. Then for each situation, design the coordinates of the 2D drawing of the insulator and set up the material attributes. The insulator testing simulation had to be fixed with the same design and altered depending on the environment. After that, the FEMM software had to be meshed to see whether the simulation had any errors, and the voltage and electricity could be seen as a result. So this is the flowchart for this project. Okay, so first find three different types of condition. Then planning the coordinate of 2D drawing in FEMM. Then draw and connect the coordinates in form of insulator. After that, set up the material properties of the condition and materials. Then declare the mesh area. If error, if it had error in mesh, then need to find three type of condition again. But if no, analysis the voltage and electric field. So that's all for the. That's all from me.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Haekal bin SHAHRIMAN and my metric number is CE190090. So today I will be presenting the FEA simulation result and how to obtain the data observation. So basically this is the single glass cap and pin disc insulator, which consists of the iron and glass and air parameter. So this figure show the voltage distribution within the length of the insulator for the normal condition of a single insulator that measure from the bottom to the top of the disc. And if we run the simulation, we can obtain the graph of voltage distribution versus strength of insulator for, in this case, which is the single. So here shows the voltage versus length graph, and this is the field intensity for the single cap insulator. So there are three conditions that will be applied in testing this insulator. First is a clean insulator or normal condition of the insulator. Next one is wet condition, salty condition, which is the contamination, and lastly the contamination condition. So the first one is the performance of string insulator in dry or normal versus wet condition. So this is for the dry condition. So to obtain the value of the voltage and the field intensity, you just simply click this button and drag the first point here, start from the bottom to the top, and we can obtain the value of the potential, which is the voltage. And this is the field intensity for the dry and clean condition. So next is for the wet and clean condition. As you can see here, we have included the water parameter. Here, iron, water, and glass. So we have also declared the coefficient for the water, which is 80.4. And okay, so we run the simulation and we can get the required voltage and energy graph. So this is the simulation that has been run, and the color here shows the density of the voltage. It starts from the high until the low, which is the bottom value is higher than the top value. And to obtain the graph, we must plot the value from bottom to the top, and we can obtain the voltage value as seen here, and also the energy intensity, magnitude for the field intensity. So, and the last one is for the contamination condition. So next is for the wet and clean condition. So here is the simulation that has been done. So to gain the value of the voltage and the energy, we must click here. Oh, sorry. We must connect the connection of these two parts here, and to obtain the value of voltage graph, we simply click here. And this is the graph of the voltage. And this is also the graph of the magnitude of field intensity. So for the last condition is with the contamination. In this case, the contamination is declared as salt. So the salt value is shown here, as you can see. This is the salt on the glass, and the properties of the salt is declared in the simulation, which is equal to the coefficient of 15. Okay, okay. And here is the run simulation and how to obtain the value of the graph, which is the voltage graph. And the last one is the field intensity of the contamination condition. So I think that is all for the simulation. So thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is SAFRAN AIMAN YAMIN. So I will present the part of our project for the subject high voltage FEA simulation result and data preservation. First, the oscillator is made up of 3 discs attached to the core with a creepage distance of 7,100 mm. Then the simulation was performed under 3 different conditions. First, dry clean, second, wet and clean, and with and without contamination. Next, study condition 1, comparison between dry clean and wet clean condition. First, the voltage distribution at the top part of the isolator, the pink color indicated that the area has a high voltage distribution, while the yellow color indicates a moderate voltage distribution. Light blue indicate in the system ground. Second, electric field intensity begin with higher value. Then for the dry and clean condition have no effect on the voltage produced by the oscillator. Figure 50 show the electric field produced by a dry clean isolator is greater than produced by wet clean isolator. The graph for the electric field distribution of isolator for wet and clean condition show that the peak value of electric field intensity is at the end. The wet clean condition has lower started value but higher value than dry clean isolator because of the value of water on the isolator surface. The pattern of the wet clean condition change. Next, study condition 2, comparison between with and without contamination condition. The majority of transmission and distribution line infrared various regions such as coastal desert, urban, suburban, and highway region. As a result, isolation is stored in this line subject to the pollution found in this area. So, figure 19 and 20, a graph of electric field strength distribution of two different isolators with and without salt as contaminant agent has shown in figure 23 and figure 24. Dry clean condition has a higher value at the end than the contamination condition because of the value of contamination on the isolated surface and in the surrounding environment. The potential difference becomes less quickly at the two end part compared to the middle part. In coastal area, the majority of isolated contamination is caused by airborne sea salt particles. Small water bubbles are released from sea wave as a result of the reaction of sea wave during stormy weather. The impact of pollution layer has increased the electric field stretch on the isolated surface, and in this case, the pollution layer is deposit salt.
Okay, so for conclusion, as a conclusion, a high voltage insulator was designed, and the insulator's characteristics are based on the insulator prototype properties option provided in the instruction. In this project, SketchUp software was used to design the insulator in 2D and 3D drawings because it is a suitable software for illustrating the insulator. The insulator was tested for the simulation to investigate the voltage and electric field strength of the insulator, which was done using FMM software and was done in 3 conditions: wet, dry, and clean contaminated. Finally, it demonstrates that the voltage is not significantly affected in all 3 conditions, despite the fact that the disturbance is still present in the insulator during a wet condition, and the electric field strength is significantly affected in all conditions. However, the effect is still tolerable for the insulator, particularly when the insulator is wet and the end has a higher value of the electric field. For future recommendations, we will suggest a test condition that combines mechanical and electrical testing. This test combines a mechanical load and an electrical load with a specific value to the insulator, which must withstand the load. Okay, that's all from our group. Thank you very much.